In this class, now I would like to explain you some standard integral formulas. Before going to learn those standard integral formulas, first let us learn the meaning of an integration. Generally, we define integration as an inverse process of derivative of a function. For example, see, if you find the derivative of f of x, we may get a new function, let it be q of x. So what it is? Derivative of this function. After that, if you do the integral of this function, then we get this f of x. And here we add a constant c. So this is the general meaning of an integration. Here what did I do? I did the derivative of this function. After the derivative of this function, I may get a function. So that I took as q of x. If you find the integral of this function, again we people have to get f of x. Here we add a constant plus c. Why we add that plus c? If you want, I can give you the reason behind it. Otherwise not required. So in this entire chapter, at the end of integral, just we have to add plus c. Okay students? So how do you define an integration? It is an inverse process of derivative of a function, or you can call it as antiderivative of a function, is known as integral of a function. So you know, to find the derivative of a function, we followed many more methods, like finding the derivative of a function by the first fundamental principle, next chain rule, uv rule, u plus or minus v rule, logarithmic differentiation, and a substitution method of derivative of a function, and doing the derivative of a function with respect to other function, and a derivative of implicit equations, like many more methods you learned. So the process of doing derivative of a function by following various methods is known as differentiation. In the same way, here also, to evaluate integral of a function, we people are going to follow some methods. By following those methods, we evaluate integral of a function. So the process of finding integral of a function by following various methods is known as integration. Okay? Right. Now let us see some standard integral formulas. So with the help of those standard integral formulas, we do integral of some functions. Okay? After that, so in the further classes, I explain you other methods. Okay students, now let us learn those standard formulas. I hope you have got the meaning of integration. How do you define? Antiderivative of a function, or an inverse process of derivative of a function is known as integration. Now let us learn some standard results. See, take this basic function, integral of x power n dx, which is equal to x power n plus 1 plus c. So this is the symbol for integration. So this is the integral operator, and this is the function which we have to find whose integral. So it is called an integrand. What it is? Integrand. What it is? Symbol for an integration. This is integral operator. So after that, what you have got? You got a result x power n plus 1 by n plus 1 plus c. So if you do the derivative of this function, again you people will get this. If you want, you can check it. Shall I do the derivative of this function? As see here, x power n plus 1 integration, differentiation derivative will be n plus 1 into n plus 1 minus 1 by n plus 1. Constant derivative will be 0. So both of them cancelled. See, what is the result? X power n. You got the function, integrand you got. Hence, the integral of this function will be how much? X power n plus 1 by n plus 1 plus c. Where n should not be minus 1. Remember that. Okay students, here whichever function is given in the integrand, so that should be differentiable function. Okay students, see here, whose integral will be how much? X power n plus 1 by n plus 1, where n is not equal to minus 1. If n equal to minus 1, what will happen? This denominator would be 0 na? Hence, so n should not be minus 1. Remember that point. Now let us go to one more function. See this, integral of root x dx. How do you find whose integral? So it has to be written x power 1 by 2 dx. Now apply the previous formula for this, so that you will get x power 1 by 2 plus 1 by 1 by 2 plus 1 plus c. Now simplify this. You get x power 3 by 2 by 3 by 2 plus c. Okay students. Now this 3 by 2 can be written 2 by 3 and x power 3 by 3 power x power 3 by 2. Even if you want, you can write it as x into root x plus c. Okay, right. Now let us go to find integral of 1 by root x dx. How do you evaluate this function integral? In the first step, you would have to write this one as x power minus 1 by 2 dx. Now evaluate whose integral? X power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. Now let us simplify this. This is going to be 1 by 2 and it can be written as 2. And what about this? X power 1 by 2 plus c, which can be written as 2 into root x plus c. Okay, right. In the next step, see, if I give you integrand as 1 by x, how do you evaluate whose integral? 1 by x integral will be log mod f of x plus c. Because if you do the derivative of this function, you will get 1 by x. Because log x derivative 1 by x, constant derivative 0. You are getting this na? Hence whose integral will be this much. So remember one thing. See here, why I kept mod, you know. Logarithms will be defined only for the positive real numbers. Hence I kept here mod symbol. Okay students. Right. Next. See, integral of e power x dx. So whose integral will be e power x plus c. Because if you do the derivative, again you will get this. Check it. Constant derivative will become 0. E power x derivative, e power x only. Hence, the integral of this function will be how much? E power x plus c. And what about integral of a power x dx? Where a is positive but not equal to 1. These are the conditions. A power x integral will be a power x by log a plus c. What are the conditions for a? It should be positive but not equal to 1. If it is 1, what will happen? Log 1, 0. So something by 0, not defined, meaningless. Hence, so this A has to follow this conditions. A should be positive but not equal to 1. If A is negative, logarithms will not be defined. Hence, the conditions for A is A should be positive but not equal to 1. So, what is the integral of A power x? A power x by log A plus C. Next, see here. Now, let us learn integrals of trigonometric functions, basic trigonometric functions. See, integral of sin x dx is minus cos x plus c. Minus cos x plus c. If you want, again do the derivative of this. So here minus cos x derivative minus sin x plus c derivative 0. Minus into minus plus you are getting. Hence, what is the integral of sin x? Minus cos x plus c. See students, right? Next, integral of cos x dx sin x plus c. Because if you do the derivative of this, again you will get this. Check it, c derivative 0, sin x derivative cos x. Integral of c. Next, secant x into tan x dx, which is equal to secant x plus c. And integral of cosec x into cot x dx, which is equal to minus cosec x plus c. Because if you evaluate a derivative of this, you will get this. What is the derivative of cosec x? Minus cosec x into cot x. Minus into minus plus. You are getting this now. Hence, integral of cosec x into cot x is how much? Minus cosec x plus c. Next, integral of secant square x dx. Integral of secant square x dx is tan x plus c. Evaluate the derivative of this, you will get this na, tan x derivative secant square x. Hence, whose integral will be how much? Tan x. Next, integral of cosec square x dx. How much, students? Minus cot x plus c you will get. Integral of cosec square x is how much? Minus cot x plus c. Evaluate the derivative of cot x minus cosec square x na. This minus into minus, which becomes positive. You are getting this. Hence, the integral of cosec square x is how much? Minus cot x plus c. So these are some standard integral formulas from basic trigonometry. Suppose if we go to the hyperbolic trigonometric functions, we get like this. Integral of sin x, sin hx, sin hx dx, which is equal to cos hx plus c. Because if you do the derivative of this, you will get this. Sin hx derivative is cos hx, cos hx derivative is sin hx. Hence, the integral of sin hx is cos hx. Next, integral of cos hx dx, which is equal to sin hx plus c. In the same manner, integral of, so secant h square x dx will be tan hx plus c you will get. And integral of secant hx into tan hx dx, which is equal to, here you will get minus secant hx. In the basic trigonometry, here you get plus, but in the hyperbolic you get minus. Next, integral of cosec hx into cot hx. Integral of cosec hx into cot hx dx, which is equal to minus cosec hx plus c. Minus cosec hx plus c. Okay, students. Next, integral of cot square. So integral of cosec h square x. Cosec h square x dx, which is equal to minus cot hx plus c. Minus cot hx plus c, because whose derivative will be this much. So these are some standard integral formulas from hyperbolic trigonometric functions. So now let us move to inverse trigonometric, some standard integral formulas from inverse trigonometric functions. See here, 1 by 1 plus x square dx. So which is equal to, you will get tan inverse of x plus c. Actually it is called a rational function. If you integrate it, you will get tan inverse of x plus c. It is one of the inverse trigonometric function. Student, you people have to observe one thing. Just I am explaining you standard integral formulas. Next, we do some integrals by following substitution method. There we get many more. Okay? But in this class, I am going to focus on only standard integral formulas, as I said to you. So here, this is one of the rational function, or you can say it as rational polynomial function or rational fraction, whose integral will be how much? Tan inverse of x. Because if you do the derivative of this, you are getting this now. Hence, whose integral will be 1 by 1 plus x square. Now, integral of. So here, students, even this can be also written as minus cot inverse of x plus e also. Because if you do the derivative of this, cot inverse of x derivative, you know, minus 1 by 1 plus x square. That minus into this minus will become positive. Hence, 1 by 1 plus x square integral will be tan inverse of x. Otherwise, it can be written as cot inverse of x. Right? Next, see, integral of 1 by root of 1 minus x square dx, which is equal to sin inverse of x plus c. Otherwise, it can be also written as cos inverse of x plus c. Okay, do the derivative of these two. Again, you will get this. Either this or this. You know, derivative of sin inverse of x will be 1 by root 1 minus x square. Cos inverse of x derivative minus 1 by root 1 minus x square. That minus into this minus will become positive. Hence, integral of 1 by root 1 minus x square can be written as sin inverse of x plus c or minus cos inverse of x plus c. Next, integral of 1 by square root of 1 plus x square dx will become sin h inverse of x plus c. Otherwise, you can express in terms of log as log of 1 plus root of x square plus 1 plus c. Integral of root 1 square root of 1 plus x square will be how much? Either sin h inverse of x. Otherwise, you can express in terms of log as log of 1 plus root of x square plus 1 plus c. And integral of square root of x square minus 1 dx. See, observe this. First variable is getting next constant. Then it will become cos h inverse of x plus c, otherwise in terms of log 1 plus square root of x square minus 1 plus c. Okay students, I hope you have understood this. So these are some standard integral formulas from inverse trigonometric functions and hyperbolic inverse trigonometric functions. Now let us see the integral of mod function. Modulus of x. Integral of modulus of x is x into mod x by 2 plus c you will get. If you want, do the derivative of this function. Are we going to get this or not? Check it. See, follow the UV rule. Keep this 1 by 2 outside. So you know. So keep this x outside. Do the derivative of modulus of x. Mod x by x. Keep this mod x outside. Do the derivative of x, which becomes 1 plus c. Send this one inside. So what do you get, students? So here 1 by 2 modulus of x plus modulus of x 2 mod x. So here constant derivative which becomes 0. So 2 cancel. Again you are getting modulus of x na. Hence the integral of modulus of x will be how much? X into mod x by 2 plus c, where x should not be equal to 0. Okay students, I hope you have understood. These are some standard integral formulas. Okay, based on this I am going to explain you some standard applications in the next class. Thank you students, thank you.